Okay, good morning. Good morning, everyone who's joining us today. Um, I'm just gonna wait for about 2 more minutes because we're not quite ready yet. It's not 11 o'clock yet, so I'm just gonna wait until everybody kind of gets settled. And so I hope everyone's back to the routine again with our live streaming virtual classroom. I think this is a new thing, new word that I'm gonna be using now. Virtual classrooms. Okay, so good morning and welcome to our virtual class and e-learning today. So first of all, I just want to welcome to people who are joining us today, and so welcome. What we're going to do is we're going to talk about lesson number 1 on exponential functions. So this is when um, the booklet says exponential functions and logarithms. It's actually not a bad booklet. It's not a long booklet, but there's a lot of things to unpack in here. So we're just going to get started right away. And so just to remind everybody, I have my live chat on, and I'm kind of always reminding myself to always look at that part of the screen so I know that some students are saying something to me because I can't really hear you. The only thing I can see are the live chat. So at some point during the lesson, please let me know if there's any question that you want me to go over again or explain some more and further. So when we talk about exponential function, I just kind of want to review what exponents does. So when this is in grade 10 and prior to grade 12 pre-cal, we looked at the exponents and what it does. So we said exponents are basically a repeated multiplication. And what we're going to do today is we're just going to look at the exponential function. Okay. So getting started with exponents, just to kind of refresh ourselves and remind ourselves what are exponents again. So when we say 3, 3 to the fourth, it really means 3 times 3 times 3 times 3. So we have 4 factors of 3. And we can, this is the exponential form. This is the repeated multiplication form. And then if you want, you can say, what's the answer to that? And that's 3 times 3 is 9 times 3 is 27. 9, so this is 9 times 9, so that's going to give us 81. So this is the standard form. Okay, so we can have a base of 3. We can have a base of 1/2. So we can say, well, what's 1/2 to the power of 4? Well, that really means 1/2 times 1/2 times 1/2 times 1/2. And to figure that out, 1 times 1 times 1 times 1. So the numerator is 1. And the denominator would be 2 times 2 times 2 times 2, which is 4. So that's 16ths. So if you have 1/2 to the power of 4, that's going to give you 1/16. Another thing that I wanted to kind of spend a little bit time on is, well, what happens when you have an exponent of 0? Okay, so what happens? So for 0 exponent, what would happen? So I can go 3 to the power of 0. So let's get rid of this brackets here. What's 3 to the power of 0? 3 to the power of 0 is 1. So if you just take your calculator, 3, and then sometimes exponents could be y to the x or x to the y or a caret key. In this case, it's 0. 3 to the 0 is 1. So any number raised to an exponent 0 is equal to 1. Okay, so that's important to that we do a review on this one. Now we looked at what happens when we have an exponent of natural number like 4, 3, 5, 2, and we looked at the exponent 0. Well, what about negative exponents? Negative exponents. What happens there? Well, what if we go 1/2? Actually, I won't choose 1/2. I'm gonna choose just 2. Let's back up. I'm just gonna put 2 to the negative 1. What would that be? Now, this is something that we learned and spent time on grade 10 pre-calculus. And when we said 2 to the negative 1, that's going to be the same thing as the reciprocal, to reciprocate the base to make the exponent a positive. So the reciprocate of the base is going to be 1/2 to the exponent of 1. So that's going to be 1/2. So I just want to show you on a calculator that it is 1/2. So 2 to the exponent of negative 1 is going to give me 0.5, which is 1/2. Okay, so let's do another example. Another example. What about 3 to the negative 2? How do we figure this out? That's the same thing as reciprocating the base. Reciprocating the base, it's 3 over 1. So it becomes 1 over 3. And then to make it a positive exponent. And 1/3 squared, that means 1 squared is 1, 3 squared is 9. So when you have 3 to the negative 2, that's really 1/9. So let's show that on our calculator. 3 to the exponent of negative 2. I got 0.111111, which is really what 1/9 is. 1/9. So we talked about positive exponent, what happens when we have a zero exponent, and then what happens when we have a negative exponent. So that's basically what's happening. Well, can we have an exponent of a half? Is that even possible? So I'm just gonna grab another piece of paper in here. So for rational exponent, again, um, rational exponent, that is something that we learned in grade 10. Grade 10 pre-calculus, what happens when we have a rational exponent, meaning some kind of a fraction or a decimal on our exponent. So let's see here. 4 to the 0.5. 4 to the 0.5. So what's that equal to? Now I'm just going to rewrite this 4 to the 0.5 into something like this. 4.5 is 1/2. So, well, what is 4 to the exponent a half? We said that that numerator is going to be what will raise the base, and then the denominator of the exponent, that would be the root. So we can rewrite as 4, 1, and square root. So this 1 goes in there, and then the 2 is the index for the root. Okay, so 4 to the 0.5, also we can say it's 4 to the 1/2, is the same thing as the square root of 4, which is 2. So just want to show that to you, that how do you enter that? So 4 to the exponent of 0.5, then it will get 2. And well, what if we have 4 to the 3/4? Okay, what if we have an exponent 4 to the 3/4? That's the same thing as 4, 3. Okay, it means it's a fourth root of 4 cubed. Okay, now this is going to be a not, I don't think it's a nice number here. It's an irrational number. So I'll just go like this. So 4 to the exponent of 3/4. I have to use the brackets. So it's going to give us a 2.8. Yeah, so it's an irrational number. So approximately 2.8284, and so on. Okay, so that's just kind of like a crash course of exponent. And the reason why I spend a little bit of time on that, because we're going to be using it for our exponential function. So let's go right into this thing. I'm going to save those so I can scan it later. Okay, so an exponential function is a function, okay? Function that can be written in the form of y equals to a to the x. And what's happening here is that a is our base, a is the base, and then the exponent x is, it's the x variable is in the exponent. And then in this particular case, what we're going to do is we're going to focus on a being a positive constant. A, the base, is a positive constant. So they're saying here that a graph of y equals to a to the x, where a is greater than 1. So think of a number that is greater than 1. So 2, 5, 9, 1.7. So that's greater than 1. So the graph would look like this. And one particular important point is that you got this point here. y-intercept at 0, 1. I'll talk about that in a second when we get into the example, why that is. So in this case, the function is increasing. It's increasing because from left to right, okay, we're always reading it from left to right. It's increasing when you go to the right. It's going up. So the graph has a y-intercept of 1, which I will explain later. And the graph approaches the x-axis but never touches it. It has a horizontal asymptote of y equals 0. So this is now has become a horizontal asymptote. Okay. Um, the graph has no x-intercept, and we'll see why that is in a second. And the domain is from negative infinity to positive infinity, or we can say x is an element of real numbers. That's another way of saying that. Notice that it's a round bracket. Okay, round bracket. You're starting from the lowest to biggest, lowest to biggest. And the range is from 0 to infinity. Now, you'll probably notice that this is also a round bracket because the graph, the curve won't touch the x-axis, right? So that we're going to have a graph like this if a is greater than 1, greater than 1. Now, what happens when y equals a to the x and then a is less than 1? And actually, to be exact, more precise, a is greater than 0 but less than 1. So think of a number that are between 0 and 1. So if we do that, the graph will decrease, okay? Decrease to the right, okay? Every time you're reading it from left to right, so the graph is going down every time we go to the right. So the function is decreasing this time. The graph has y-intercept at 1, okay? So that's the graph approaches the x-axis but never touches it, and again, that's the asymptote. The graph has no x-intercept. The domain is negative infinity to positive infinity, or we can say x is an element of real numbers. And same thing with this. The range is 0 to infinity. Another way of saying that is y is greater than 0. Okay, remember, it's not touching the 0. It's always going to be hovering above 0. So we should write that down here as well. So y is greater than 0. Okay, so that's just a little bit of introduction there. Now we're going to get into the example. Let's see what that looks like. So example number 1 says sketch the following exponential function. Sketch a following exponential function. We have y equals to 3 to the x. Now before I begin with this, what I'm going to do is we're going to start off with what we call a table of values. When we're starting to learn a function, we can create a table of values and see what that looks like. So you can say table of values here. I'm going to put it right there. Table of values. So I'm going to have my x and y. Okay. So I'm going to pick some values that are appropriate for x. Remember from the previous page, x values could be any values from negative infinity to positive infinity. So I'm going to pick negative 2, negative 1, 0, 1, 2, 3. Okay, so from here, if x is negative 2, then y is going to be 3 to the negative 2. Okay, well, what's 3 to the negative 2? That's the same thing as 1 over 3 squared, which is 1/9. Okay, so you can put that on your calculator, 3 to the negative 2, but that really means translating it into a positive exponent, changing it to positive exponent. And to do that, we need to reciprocate the base. So 1/9. What about this one here? If x is negative 1, so that becomes 3 to the negative 1. So that makes it 1 over 3 to the exponent 1, which is 1/3. Let's take a look at the 0. If x is 0, then it becomes 3 to the 0. And when we were summarizing or reviewing what we learned in grade 10, we said 3 to the 0 is equal to 1. And here, 3 to the 1 is 3. 3 to the 2 is 9. And then 3 to the 3 is 27. Now, as you can see, it starts to increase so fast. So it starts with 1 and then 3, then 9. It, it's always 3 times from the one before. So now what we're going to do is, okay, I think this is supposed to be is. Is the function increasing? We have to state whether the function is increasing or decreasing. Now we have to, well, we don't have to get the graph going to see that, but we can say the function is going to be increasing. The function is increasing. And how can we say that it's increasing? We can look at our equation, our function. When the base, let's bring that down here. When the base is greater than 1, when the base is greater than 1, it's going to increase. The function is increasing because base is greater than 1. Okay. Okay. Now, what are the intercepts or intercepts? Let's see here. Let's graph it first because we want to see the visual. So at negative 2, it's going to be 1/9. So it's going to be right there. 1/9 is 0.111111. And then over here, if x is negative 1, y is 1/3. So if x is negative 1, y is 1/3. So it's going to be right there. Okay. When x is 0, y is 1. X is 0, y is 1. When x is 1, y is 3. 1, y is 3. And then when x is 2, it's going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'll just go like that. So this is 1. I have to state my scale in here because they didn't give that to us. I can go 1, 2. Okay. So as you can see, our graph is increasing to the right. So in this particular case, what are the intercepts? So intercept, there's no x-intercept, no x-intercept, but there's a y-intercept. The y-intercept is when x is 0, y is 1. Y-intercept would be is 1. Um, the equation of any asymptote. So the asymptote is right here. Y is equals to 0. The domain is x as an element of real numbers, or from negative infinity to positive infinity. Okay. Negative infinity to positive infinity. And then the range is y greater than 0, or 0 to infinity. Okay. Both of these are round brackets. Okay. So that's basically that. Now let's go ahead and I'm gonna wait a little bit and see if everything's okay. Now let's take a look at this one here. Y is equal to 1/2 to the x. Okay, well, in this case, the base is 1/2. Okay, so the base is 1/2. Now, is the function increasing or decreasing? So is the function increasing or decreasing? Well, we can actually figure that out right now by looking at the function. In this case here, the function decreases. And how do we know? How do we know that the function decreases? Because the base is between 0 and 1. Okay, so okay, because the function is the base of the function is between 0 and 1. So again, what we're going to do is we're going to create a table of values in here. Okay, we'll start off with table of values and then we can ease out on that one as we become more familiar with this. So table of values. Okay, so what we're going to do is we're going to go -2, -1, 0, 1, and 2. Okay, let's see. So if x is -2, it's going to be 1/2 to the -2. Okay, 1/2 to the -2. And then what happens when you have a negative exponent? We can change it into a positive exponent by taking the reciprocal of the base. So this is the same thing. 1/2 to the -2 is the same thing as 2 over 1. So reciprocate the base, changing the exponent to a positive. So now what's 2 to the power of 2? So that's going to be 4. And then 1 to the power of 2, which is 1. So it's going to be 4. Now let's 1/2 to the -1. We're going to change that into a positive exponent by taking the reciprocal of the base. It's going to be 2 over 1 to the 1, which is 2. Okay. And then 1/2 to the 0. And then here, anything to the exponent 0 is going to be 1. So that's, and then keep going. 1/2 to the 1 is going to be 1/2. And then 1/2 to the exponent 2, that's going to be 1/4. As you can see, as as the x value increases, the y value gets decreases. As I'll write that down. As x value increases, the y value decreases. Decreases. Okay, so we're going to have these points going over here. So it's -2. Let's go here. -1, -2, -3, -4. 1, 2, 3. This is 1, 2, 3, 4, 5, 6. So if x is -2, y is +4. -2, +4. So there's that point right there. When x is -1, it's going to be +2 right there. When x is 0, y is 1. So that's that point there. When x is 1, y is 1/2. So that's there. And when x is 2, y is 1/4. Okay? So the graph goes this way. Okay? It decreases. So what are the intercepts? What are the intercepts? Because the x-axis is our asymptote. Y equals 0. That's our asymptote. Then our graph doesn't cross the x-axis. That means there's no x-intercept. So intercepts, no x-intercept. But what about the y-intercept? So this is the y-axis. It crosses the y-axis at 1. So y-intercept is equals to 1. Okay. The equation of the asymptote, again, that's y equals to 0. The domain is x is an element of real numbers, or from -infinity up to +infinity. The range is y greater than 0 or 0 to infinity. So that one's not so bad. It's pretty straightforward. Okay. If you have any questions, you can send me a message about that one. Okay. And if you're just joining us just now on this live stream, just keep going. Okay. And then you can always play this back and review what we just talked about. Okay. So if you're just joining us just now, and welcome. Now this one here is y equals to e to the x. Okay, now there's a little bit of kind of an explanation what that e is. So the number e frequently occurs in mathematics, especially in calculus, is an irrational number. It's an irrational number. It means a non-repeating, non-terminating value. And e is approximately 2.7. Natural logarithms are commonly used throughout science and engineering. We'll talk about that logarithm later on. But right now, we're going to use the base e. Base e is 2.7 approximately. Now, the question is this function increasing or decreasing? So the function is going to be increasing. And how do we know that it's increasing? Because the base is greater than greater than 1. Okay, so because the base is greater than 1. Now, we take a look at this one in here. What are the intercepts? Now, we're starting to see some stuff in here that if it's increasing, if it's increasing, then it's gonna go this way. I'll start off with table of values. Sometimes it's nice to kind of see more points to it. So x and y, I'm gonna start with -1, 0, 1, 2. Okay, just that part here. So that's e to the -1. So e to the -1. Now, I know that everybody has different calculators, but it's a little bit challenging to explain this because each one of us have different calculators. But if you have a calculator, look for e to the x. As you can see here, I have one right on my calculator here. It says e to the x. So it's already ready there. So I can go second function, e. So e to the exponent of -1. E to the -1. That gives me, okay, let me try that again. Second function, e to the -1. Oops. Second function to the -1. It's approximately 0.367. Approximately 0.367. Okay. What about e to the 0? Okay, now that's easy because e to the exponent 0, anything to the exponent 0 is 1. So that's that. E to the 1. Well, that one again is also easy because e to the 1, that's just going to give us the e value, which is approximately 2.718, and so on. Okay, so these are approximate values. And then e to the 2, so so I'm just using this button in here. And of course, each of us have different calculators. E squared is going to be 7.389. 7.389. So if we were to graph that, and it becomes -1, -2. So if x is -1, this is 1. Just going to state my scale for a second here. So if x is -1 and it's approximately 0.3, so somewhere there. When x is 0, so x is 0, y is 1. So x is 0, y is 1. If x is 1, it's going to be 2.7. So it's just approximately right there. And if x is 2, it's going to be 7.38. So if x is 2, it's going to be 7.38. So this is 7 there. It's going to be right up there. So the graph, so even if the base is 2.718, it still has the same characteristics as the graphs that we've seen from previous example. So yeah, so that function is increasing, and now we can see it's increasing, right? As x increases, the y also increases. What are the x-intercepts? In this case, no x-intercept, but the y-intercept is 1. Equation of the asymptote, so the asymptote is still here. So y equals 0. The domain is from negative infinity up to infinity, or x is an element of real numbers. And then the range is from 0 to infinity, or y is greater than 0. Strictly greater than 0, not greater than or equal to, because remember, it doesn't touch the 0. Okay. Now this one here, we're starting to transform the function. Okay, we're starting to transform a function in here. So y is equal to 2 to the x plus 3. Now we got to think about what we've done before. So every answer to 2 to the x, we have to add 3. And we just did transformation a couple of units ago, and we said that actually trans um, um, increases translating. That's what I'm thinking about. Translating the function 3 units up. So if you want, we can figure that out. Okay, so everything is translated 3 units up. Okay, so we can, if you want, stable of values for a second, x and then a y. So let's just start with a negative 2, negative 1, 0, 1, 2. Okay. I'm just going to do this very, very quickly, and let's see. So if x is negative 2, then that becomes 2 to the negative 2 plus 3. Okay, so what does that equal to? 2 to the negative 2, that's going to give us 1/4. 1/4 plus 3. So that's going to be 3 1/4. Okay, so if you want to do that on your calculator, certainly you can do that. So 2 to the exponent of negative 2 plus 3. So 3 1/4, so 3.25. This one here, 2 to the negative 1, so x is negative 1 plus 3. So 2 to the negative 1, that tells us it's a half. A half plus 3, so that's going to be 3 1/2. And when x is 0, so it's going to be 2 to the 0 plus 3. 2 to the 0 is 1 plus 3 is going to be 4. And then 2 to the 1 plus 3. 2 to the 1 would be 2 plus 3 is going to be 5. And then 2 to the 2 plus 3, that's going to give us 4 plus 3 is 7. So now we can graph those points. So negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. And then I want to make sure I go up to 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm more than 7. So negative 2 is 3 1/4. So 1, 2, 3, 3 1/4. If it's negative 1, it's 3 1/2. Negative 1 is 3 1/2. Bring this down a bit. Okay. X is 0, y is 4. 1, 2, 3, 4. 1, 5, so 1, 5. 2, 7, 2. Okay, so the graph goes like this. Oops, I missed that X. So the graph kind of looks like that. Okay. So when you look at that one, it looks like the graph was translated 3 units up. Okay, so this number here, in terms of translation, this is going to be graph translated 3 units up, right? So if everything gets translated up, oh, you know, um, even our asymptote also gets translated 3 units up. Initially, if we have just 2 to the x, the asymptote is right on the x-axis, but even that gets translated up. So I'm just going to do that right there. So y equals to 3. Okay, so is a function increasing? Yes, increasing. Because why? Because it's increasing because the base is greater than 1. Greater than 1. Greater than 1. So the base is 2, which is greater than 1. Any intercept, so well, there's no x-intercept, no x-intercept. What about our y-intercept? Our y-intercept, so where's the y-intercept? The y-intercept is when x is equals to 0. So that equals to 4. Equation of the asymptote is y equals to 3. The domain still, you can plug in any values for x, so it's from negative infinity up to infinity. Or we can say x is an element of real numbers. And then the range, okay, now the range has changed. Everything has shifted up 3 units. So our range is 3 to infinity. But it's not going to touch 3. Or we can say y is greater than 3. Okay? So I like this because we are kind of mixing up our exponential function here and also the transformation topic that we just did 2 units ago. Okay. Hope you're still doing okay. If not, always I'm once in a while glancing on the chat. If you have any questions, feel free to ask. Okay. Now, when we get into something like this, we're going to get into the transformation of exponential function. Transformation of exponential function. Okay, let me just grab a book. Okay, so I think what I'm going to do It's just looking at our notes in here. Um, I don't want to speed things through and it gets overwhelming. So what we're going to do is you have some questions assigned in here. So I'll give you a little bit of time to just work on some of the questions, and then we'll finish off the notes tomorrow. Okay, hope that's okay with you, because I know that some of you are still working, and some of you have kids at home. So what we're going to do is pause up to that particular point and get you to do some questions from the book. It's going to be from page 349. Page 349. Do question number 3. So that one is very, very straightforward, identifying whether it's increasing uh, or decreasing, and if it's an exponential function. Um, and then now it says here, doesn't give you that. I'm also going to assign question number 6. Okay. Certainly you can do number 6 without technology. Okay, so you can do that trying without technology, and you can use table of values. Okay, use table of values. And then question number 7. Question 4. Question 7. And I think that's it for now. Okay, so we're gonna ask you to do question 3, question 4, and question 7, and question number 6 without technology. Okay, so this is what you're gonna be working on for the rest of the period. And I highly encourage you to to give those practice questions a try, and because it gets easier when we spend the time to do the practice questions. Okay, so I'm gonna leave that with you. I'm gonna have my email open if you have any questions, and if you haven't finished the test, make sure you hand it in today. Okay, so have a great time working on those 4 questions, and I'll talk to you later. I'll talk to you soon. Okay, have a good afternoon. Bye.